able to take us on to the next one. Hi everyone, this is Miss Bowen from Pep Practice. We have practice Pep April 10, 2021. Or you can pay at 51 Duke Street, downtown.
Again, hi everyone. I hope you're all doing well today. Today we're continuing on the problem solving process to solve a problem using a diagram. So the worksheet that was shared last week, that is something that you can also practice. I'm going to share another worksheet for this week's class. It's from the same website, however, it's a different web page. The web page is in the chat. I'm going to be going to the document shortly. So we're recapping the problem solving steps, and the problem solving steps are to understand the problem, to make a plan to solve the problem, and carry out that plan. And then the last thing that we're going to be doing for that process is to look back at the answers, but not all the answer, the question, to make sure you did the correct thing in the first place. Is everyone on the link?
Yes, miss.
Okay. I'm sharing the link to the screen. All right, so there's a scenario there, and that in that scenario, we're going to be finding the problem, and there is what we're going to find the problem, as I said, to understand what it's asking you to do, and then we've already made the plan, which is to draw a helpful diagram or a picture to solve the problem. And we're going to carry out that plan and then look back over at our answer. So the scenario says that Kate is trying out a new cake recipe. The cake recipe said to add 2¼ cups of flour. The cake turned out to be too moist. She tried the recipe again, but added a 1/3 cup of flour to the recipe. The cake was much better this time. How many cups of flour did cake add in all? I'm going to highlight the problem. Okay. So let's read over the problem one more to get an understanding. Kate is trying out a new recipe. The recipe said to add 2¼ cups of flour. The cake turned out to be too moist. She tried the recipe again, but added a 1/3 cup of flour to the recipe. The cake was much better this time. How many cups of flour did cake add in all? Christina, did you read the problem?
Yes, miss.
Okay. So as I said, we are problem solving using the draw a diagram strategy. However, we're going to use another problem solving strategy, which is to identify keywords and clue words. Christina, from the problem, can you see a keyword? Are you seeing a keyword?
Yes, Miss.
And what is the keyword that tells you what operation that you're going to be performing on the problem?
Miss, in all.
In all. What operation are you going to are you going to be performing when you see the word in all?
Miss, adding.
You're going to be adding. So when we see in all, it tells us that we're going to be adding. I want you to go back over, Christina and Michael, to read the problem once more and then try to figure out what it is asking you to do, okay? Have you finished reading the problem, Michael? Have you finished reading the problem, Christina?
Yes, Miss.
All right, can you tell me what is the problem asking you to do?
Miss, the problem is asking to find out how many cups of flour Katie added.
Yes. So it spoke about Katie adding 2 1/4 cups of flour initially, and then she added another 1/3 cup of flour, and it wants to know how much flour did she add to the cake in all. All right.
Yes, Miss.
So problem solving with diagrams. When we draw a diagram or a picture, this is a strategy that helps us to solve many different problems involving fraction. The first thing that we should do when approaching the problem is to identify the given information and what the problem is asking for. So here, hold on to where it says example. So you're passing the example with John's cake, and then you're going to move further along, and then you're going to see the scenario with Shannon's miles, how much miles Shannon jogged, and we're going to move on to the one that says examples, example 1. Are you there as yet?
Yes, Miss.
So the problem with Katie's recipe is that she started out with 2 1/4 cups of flour, but then added 1/3 of flour, 1/3 cup of flour to the recipe. So in order to get the answer, we know that we need to add the quantities to find the total amount of flour she used. So we're going to be adding 2 1/4 plus 1/3, right? But we're not going to be using the method of where we generally add. What we're going to be doing is to draw a diagram to solve our problem, all right? So let's go to the whiteboard and try to flesh out this problem. All right. So the first thing that we're going to be doing is representing the amount of cake. Sorry, the amount of flour that was placed in the cake first, all right? We can do that by drawing fraction bars. And it says that, let me do the typing of the description. Let's give the diagram a name first. Katie's cake recipe. Right? And then we can say that Katie, I'm going to the notes. It says that Katie started with 2 1/4 cups of flour, but then added 3 sorry, 1/3. So let's start with the 2 1/4 first. So what we're going to be doing is drawing the bars to represent the 2 1/4, right? Before we can begin with the fraction though, we know that the denominators are 1/4 and 1/3. The denominators of 1/4 and 1/3 are 4 and 3. All right. So let me write this information down first, and then we can go ahead and look at Katie's. Katie added 2 1/4 cups of flour, right? So Katie added 2 1/4 cups of flour. Fair enough? So that's what we're trying to represent first. So we can represent this as 1 of the whole. So we're going to shade entirely this fraction bar. We're shading this 1 fraction bar to represent 1 of the whole. So we're shading this whole completely. Let me draw another fraction bar, roughly about the same size to represent the next whole, because there it says that there's 2 1/4. So we're trying to get 2 wholes. To find 1/4 of the fraction bar is going to be a tad bit tricky, seeing as though we don't know what a 1/4 of what the whole is. So we don't know currently how many parts the whole is cut into. So that's the 2 whole. So let's represent 1/4 now, but before we can represent 1/4, I'm going to put down the other information about the next. The next time she added the flour, how much flour she added. So I can say Katie then added 1/3 cup of flour. So she added 1/3, and we know it's 2 1/4. First thing we're going to find is the LCM, which is the lowest common multiple. And the lowest common multiple, a multiple is a number that is multiplied by the given number. When you multiply 2 factors, you get a multiple. So say for instance, 4 is a number and 3 is a number. When you multiply 4 times 1, that's a multiple of 4. 4 times 2, that's a multiple of 4. And we know that we can multiply 4 times 3, which is a multiple of 4. When we talk about common multiples, we're talking about the multiple that's common between both numbers, the multiple that's common between 4 and 3. In order to find the common multiple of both numbers, we can multiply them by each other, and that's where we'll get 12. I'll do another short video that teaches how to find multiples and common multiple, or common multiples, but we're looking for the least number that can be multiplied by either of these numbers, and we'll get the product. So when we multiply 4 times 1, 4, that's not a common multiple of 3, because when you multiply 3 times another number, you will not get 4. So 12 is a common multiple of both, because when you multiply 4 times 3, you get 12, and when you multiply 3 times 4, you'll get 12. So we can multiply both of them and get the common multiple, and that would be the lowest common multiple. They have other common multiples such as 24. Both 4 can go into 24 and 3 can go into 24. We also have 48. Both 4 can go into 48 and both 3 can go into 48, but the least multiple, the lowest one, is 12. So we can say that 12 is the lowest or the least common multiple, and we represent that by using the acronym LCM. And let's put it like this, LCM. So 12 is the LCM. So that's how we know what the whole is. So the whole is 12 because 12 is the LCM that both of these numbers will go into without leaving a remainder. Or the number that both of those numbers can be multiplied by a number to get. So we can get to cutting up our fractional bar, so we can get the pieces. The 12 sections are 12 pieces. So let's go 1, 2 pieces, 3 pieces, 4, 5, 6. That's halfway. That would have been half of it. 7, 8, 9, 10. I'm going to cut this in 2 to make 10. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So that's 12 pieces. The whole is cut into 12 pieces. And for everything we really do, we want to put a description so we can look back at our diagram and see where, if we went wrong or what we did overall. The whole is cut into 12 parts, so we can take 12 pieces either way. So now we can find a quarter of this 12, and that's how much we will know is the quarter of the cup. So we have the 2 holes here. This is 1 hole, 2 hole, and now we want to get a quarter here. So we can find out a quarter of 12 by dividing 12 by 4. 12 divided by 4 is, what's 12 divided by 4, Christina?
3, miss.
3. So we put 3 here as the answer. So now we know that we must shade 4 parts. Sorry, 3 parts. 12 divided by 4 is 3, so we're shading 3 parts. So we can, sorry, also write that down, that a quarter of 12 is 3, so therefore we need to shade 3 parts. All right, so let me continue to shade now while they're copying down the diagram, right? So we're shading 4 parts. And sorry, 3 parts, and that's 1/4 or a quarter of 12. So that's the 2 1/4 now represented on the diagram. Are you seeing that, Christina and Junior?
Yes, miss. Yes, miss.
So now we need to find out what is 1/3 of 12. Similarly to how we divided 12 by 4, to find out what is a quarter, we can divide 12 by 3 to find out. I see your hands raised, Christina. What's the answer? Can divide 12 by 3.
The answer is 4.
Yes, I'm going to get 4. So 1/3 divided by 3 is 4. So all we need to do is shade another 4 sections, and that's how we represent how many cups of flour Katie added to the recipe in all. And we know in all is add, and that's why we're adding on the 1/3 rather than subtracting, all right?
Okay, miss.
So then we added on 1. Could have used another color altogether to represent this portion. So let me do that. So we're shading on now 1/3 of 12, or 1/3 of the whole part that the fraction is cut into. And that's 4 parts. And then this will represent how many cups of flour was added to Katie's recipe to make the cake. So what we can now see, and I think that's what we have been seeing throughout the process of us using a diagram to solve the problem, that when we finish drawing our diagram, when we have done all the different parts of drawing out our diagram, we can clearly see our answer, because here we can see that now two holes and 1, 2, 3, 4, 5, 6, 7 portions. So we can say 2 holes. Write the description now. That 2 Katie added 2 holes and 1, 2, 3, 4, 7 out of 12 cups of flour to the recipe. Are you seeing that, Christina? Sorry.
Yes, miss.
I'm going to give you the time so you can copy it. Are there any questions?
No, miss.
Okay. So let's revisit the question. It says, Katie is trying out a new cake. The cake recipe said to add 2 1/4 cups of flour, and that's what we represented first on using the fraction bars. The cake turned out to be too moist. She tried the recipe again, but added a 1/3 cup or 1/3 cup of flour to the recipe. The cake was much better this time. How many cups did Katie add in all? So based on the diagram that we drew, we can see from the 2 solid bars that Katie added that Katie added 2 1/4, and that was represented by the red shaded portion of the diagram. And then we represented 1/3 of the 12, which is the yellow shaded there with 4 sections shaded. And in total, we can count it to say that this is 1 whole, 2 whole, 1, 2, 3, 4, 5, 6, 7. And we know that this is 12 sections or 12 parts. So we can say that Katie added 2 and 7/12 cups of flour to the recipe, right?
Yes, miss.
Are there any questions? Are there any
No, miss.
questions? Okay. So that's basically where we end our session today. Again, when you're looking at solving the problem, the first thing we want to do is to understand what this is asking us to do. And that's why we were able to move to draw out our diagram or depict out our diagram. Once we're finished doing so, then we can proceed to using our pen and paper, in my case, the whiteboard and the annotation tool, to flesh out our problem so we can see clearly what is taking place through the plan. And in this case, the plan was to use a diagram to represent the information. And what we did now was to carry out the diagram. And then just now we look back at what we did, right? So we can clearly say, this is the correct answer because we can see what is taking place. And that's why it is essential for us to use diagrams, because we're hardly going to be able to go wrong when we use the diagram, when we can illustrate and clearly see by visual representation what we're doing in the problem solving process. All right.
Okay, miss.
All right. So this is where this session will end for this week. Again, the recording of this session is on the YouTube page, and you can visit the page so you can watch over the video and relearn the strategy or to solidify what you would have already learned.